Hi, and welcome to another installment of Math Basics, Mr. Besh. Today we talk about the differences between experimental and theoretical probability. Now, the first one we're going to explain is theoretical probability. We are going to use the event of simply flipping a coin. This is the easiest one, and hopefully this drives the point home to students. If I ask a student what's the probability of flipping a coin and getting heads, the student would say 1/2. Now, if I ask what's the probability of flipping a coin and getting tails, the student would tell me the same thing. The reason they do so is the top number of every probability represents how many chances you have to actually succeed in your endeavor. Which means if you flip a coin, there's only one heads and there's only one tails. So you'd only have one chance of doing it. The bottom number represents how many different things can actually happen. You all know when you flip a coin, you could either get heads or tails, and that's the reason why this is a 2 at the bottom. Now, this is the theoretical probability. Remember, every single probability can be expressed as a decimal and also as a percent. So this percent right now we're looking at is 50%, or like we refer to as 50-50. Now, if we conducted an experiment, we gave you a quarter, and I ask you to flip it 10 times. Every time you flip the quarter is an event. When you record this, what you're actually doing is you're conducting a trial, just like a science experiment. You all know that there's a possibility that if I flip the coin 10 times, I could get something like this. Tails, 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 heads, tails, heads, heads, tails, tails, heads. This is a possibility. We all know that every time you flip a coin, you're not going to get heads the first time, then tails the second time, then another heads, then another tails, then another heads, then another tails. I mean, it could happen, but the chances of that happening in that pattern or that order is very slim. If the question was asking you, well, what's the experimental probability based on a trial that you did? Well, here, this example that we just did right here, we did 10 events. Every time you flip a coin is an event. And what happens is this first trial has 10 events in it. If I were to go through and highlight all of my tails here, take a look, I got 6 of them. So now 6 out of 10, and take your fraction and put it into lowest terms. And now what ends up happening is my probability is 3/5. When you conduct trials that have small amounts of events, usually your experimental probability will be significantly different than your theoretical probability. We all know that 3/5 is significantly different than 1/2. But here is how the experimental probability and theoretical probability start to make a connection with one another. If I were to ask you to create more events in this trial, doing this more and more and more, okay? So then look what happens, right? So let's add a few here, right? Let's take this number up to say 24 now. No longer are we dealing with 10. So let's add 14 more. So then I get another tails and then heads and then a tails and then a few heads in a row. And then I get another tails, another 2 heads, another tails, heads, tails, heads, heads. So now what I have here is I have 14 more that I added to my original 10 events. Now let's take a look. Now let's see what we're doing here, okay? If I were to go down and try to figure out how many tails I have now, as my events here increased by 14 to 24, my trial now has expanded. The larger and larger your trial is, the closer and closer your experimental probability would reach what we're looking for, which is the theory. So let's take a look. Now when I have tails, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now my probability here out of 24, okay, is no longer 6 out of 10, but my probability is 11 out of 24. And guess what? We're getting closer and closer to that 50-50 mark. And if we added another 10 events to this, and then another 10 events to this, and we kept going and going and going, slowly but surely that experimental probability would be very, very close to the theoretical probability. And that's the connection between both of these. So I hope this makes sense, and I hope you found this video on experimental and theoretical probability helpful.